We did a little bit with making predictions with our data. It's like given a certain x value, plugging it into GeoGebra to see our expected output. It's kind of like finding our y hat values given x. But sometimes we need to be careful of how we do this. So say we wanted to fly a destination that was 500 miles from Baltimore. So what this is doing is we're estimating airfare, and it's that if we plug in 500 into our equation. So if we go to GeoGebra, where it has that symbolic evaluation there, this is the idea of plugging in 500, which in terms of the graph here, what it would look like is going to 500 on this number line, and it's where are we landing on our predicted line here. So plug in 500, that gives us an output of 150.39. So with this, if we're traveling 500 miles, it's that we predict to pay $150.39. What we could think here is like, how much do we trust this value? Which, with our data, what we can see is we have quite a bit of information here. We know what's happening below 500, we know what's happening above 500. So if this model has, it has a moderate strength to it, so there's kind of a level of trust with that. But we can pretty much trust that value. We have data around it, and we know we have a moderate strength. So we can trust that $150.39. But then in the next question, we go, what if we travel to Australia? So what if X is 9,782 miles? And estimating our airfare for that scenario. So we go into GeoGebra and plug in this 9,782. We get this outcome of 1,424.43. Now, that would be our airfare traveling that far. But now in terms of how well we can trust that value, well, looking at our data, we don't really have anything close to that distance from our initial data. We basically go up to a distance of 1,500. We have nothing close to a distance of 9,000. So we don't really know if this linear trend continues. We know this trend works great from about 200 miles to 1,500 miles. But beyond that, something else could be happening. There could be a grouping of different data, like this goes into the idea of international travel, could be different. Same thing with the next example where it's a distance of 10 miles. If we plug in 10, gives us a value of like $83.14. But we don't really have any information near that value, so we don't really know if we can trust that as a predicted value. So this is a difference between interpolation and extrapolation. This first example was interpolation. It's the idea of estimating within your data set, and you can really trust those values. That's where you want to use these predictions. But for these two cases of B and C, this is extrapolation, and we just want to be careful with this idea because we don't really know if the trend continues out that far. For traveling internationally, usually traveling such a short destination, you'd be using a private plane, so that could change the cost completely. You wouldn't really be using an airline. So you just want to be careful. If we're extrapolating, just say that that might not be true because we don't know if the trend is continuing. So that's how we make predictions with our data.